sklearn, decomposition, factor analysis a deep dive. Factor analysis FA is a statistical method used to identify underlying factors or latent variables that explain the relationships between observed variables. It is a dimensionality reduction technique that aims to represent a set of observed variables with a smaller set of unobserved variables factors. In simpler terms, FA tries to find the hidden structures in data that explain its variation. sklearn, decomposition. Factor analysis is a class in the scikit-learn library that implements factor analysis using maximum likelihood estimation (MLE). It provides a powerful tool for exploratory data analysis, helping you understand the underlying structure of your data and identify important factors that drive its behavior. Understanding the concepts. 1. Observed variables. These are the variables you directly measure in your dataset. 2. Latent variables factors. These are the unobserved variables that are hypothesized to influence the observed variables. 3. Factor loadings. These represent the strength and direction of the relationship between each observed variable and each factor. A high loading indicates a strong relationship between the variable and the factor. 4. Communalities. These measure the proportion of variance in an observed variable that is explained by the common factors. 5. Uniqueness. This represents the proportion of variance in an observed variable that is not explained by the common factors. 6. Factor scores. These are the estimated values of the latent variables for each observation in the dataset. Using factor analysis in sklearn. 1. Initialization. N components. The number of factors to extract. This is a key parameter that needs careful consideration based on the problem and data. Rotation. A method used to rotate the factor loadings to obtain a more interpretable solution. Common options are varimax orthogonal and promax oblique. Random state and integer to ensure reproducible results. Tolerance for the optimization algorithm. Maxiter. Maximum number of iterations for the optimization algorithm. 2. Fitting the model. FitX fits the model to the data X, where X is a matrix of observed variables. 3. Exploring the results. Components. A matrix containing the factor loadings. Each row corresponds to a factor, and each column corresponds to an observed variable. Uniqueness. A vector containing the uniqueness values for each observed variable. Transform X generates the factor scores for new data X. 4. Interpretation. Examine the factor loadings to identify the observed variables that are strongly associated with each factor. Look for patterns in the factor loadings to understand the meaning of each factor. Use the factor scores to group observations based on their latent variable values. Key applications of factor analysis. Dimensionality reduction. Reduce the number of variables in a dataset while retaining the most important information. Data exploration. Gain insights into the underlying structure of complex data. Feature engineering. Create new features based on the extracted factors. Predictive modeling. Use factor scores as input variables for predictive models. Strengths of factor analysis. Reduces complexity. Simplifies data by identifying underlying factors. Provides interpretability. Allows for understanding the relationships between variables in a more meaningful way. Handles correlated variables. Can effectively deal with datasets where variables are highly correlated. Limitations of factor analysis. Subjective interpretation. The interpretation of factors can be subjective and depend on the researcher's perspective. Assumptions. Requires the data to meet certain assumptions, such as linearity and normality. Sensitivity to outliers. Outliers can significantly impact the results of FA. Example: Python. From sklearn, decomposition import factor analysis. From sklearn, datasets import load iris. Load the iris dataset. Iris load iris. X iris. Data. Initialize and fit the factor analysis model. FA factor analysis N components 2. Random state 42. FA. Fitx. Print the factor loadings. Print FA. Components. Transform the data to obtain factor scores. Factor scores FA. Transform X. Analyze the factor loadings and factor scores to interpret the results. Important notes. Always examine the assumptions of FA before applying it to your data. Experiment with different numbers of factors to find the optimal solution. Use appropriate rotation methods to improve the interpretability of the results. Consider using other dimensionality reduction techniques, such as principal component analysis (PCA), if FA is not suitable for your data. By understanding the concepts and techniques of factor analysis, you can effectively use it to explore your data, extract meaningful insights, and build more robust models.